All right, so let's start. So this is going to be a quick talk. However, we're going to dig deep on the best practices and the veteran moves when dealing with complex machine learning engineering projects and workflows. So of course, if you were to, let's say, learn engineering techniques using, let's say, serverless technologies and serverless concepts, and also use containers to solve your requirements, creating a simple application, if you think about it, is kind of straightforward and simple. But once you have to deal with real requirements, that's where things get a bit trickier. So we'll talk about those details in this talk, and we'll share also how do you deal with machine learning engineering requirements along the way. So to start, I'll introduce myself. I am Joshua Arvin Lat. I am the Chief Technology Officer of NewWorks Interactive Labs. I'm also an AWS machine learning hero. So currently, there are, I think, 32 machine learning heroes around the world. And then I'm also the author of the book, Machine Learning with Amazon SageMaker Cookbook. So the funny thing is that today is actually the launch date of this book. So it took me about 6 months to 9 months writing this book last year during the pandemic. And I made use of the extra time I had since I was able to save about 3 hours of commute every day. So it took me about 6 months to write almost 900 pages. And then the final version has 762 pages. So feel free to read this, especially if you want to be an intermediate or advanced user of doing machine learning stuff in the cloud. All right, so to start off with, no machine learning talk is complete without defining what machine learning is. So machine learning, the simplified way to describe it is, if you're trying to do something and it's not straightforward and you cannot hard code it using your normal programming logic code, and you're using, let's say, data and generalizing a model on top of, let's say, training data, and trying to, let's say, use that model to check if this is a cat or not a cat, especially for new images, then that's one way to describe machine learning. Of course, there are different types, let's say supervised, unsupervised, and so on. But for now, the goal here is to deep dive on how to do machine learning engineering. So basically, machine learning and engineering combined in order to do something like this. So if you have other requirements that involves machine learning, then having that engineering skills and platform and everything that helps automate things, that's going to be our topic for today. Also, here's the simplified process. So if you have been doing machine learning for quite some time, you're pretty aware that this is not linear. You should be aware that this involves, let's say, something like loops, where after you perform a certain step, you're going to go back and maybe retrain the model at some point. Because of course, the models in production do degrade after some time. But first, let's to make things simplified first. The machine learning process involves data collection. You will need the data in most cases. And then you prepare the data and clean it. And then you do data visualization and analysis to understand how your data looks like. You perform the feature engineering task and steps. And then you perform model training and hyperparameter tuning. So when you have the hyperparameter tuning step, that's where you have the opportunity to produce multiple models and then choose the best one. Because what hyperparameters are is, think of them as configuration parameters before your training jobs start. Yeah, so we'll talk about that later also, and how we can use the cloud and serverless and containers to solve that specific item. Next would be model evaluation. The goal of the machine learning process is not just to create a model. The goal is to create a model that solves a specific problem best, meaning there's some sort of metric or way to measure it, and if there's less error, then that's probably the model that we're going to choose. Finally, we deploy the model. Of course, after you deploy the model, a consumer or some other system would be using that model through some sort of API. So if your model gets deployed here, then you have a mobile application, your mobile application needs to be able to talk to that API. So if you look at this simple process, you'll start to realize it will involve both machine learning and software engineering and DevOps capabilities to get this done. For one thing, if you have deployed a model, it would be weird to assume that if you have a new model, how do you find a way to replace an existing model already live in production? How do you know which model is better? Do you perform A/B testing and so on? So the last part, model deployment, is actually one of the trickier parts that we have to deal with, because in addition to dealing with deployments, you also have to monitor your models there, because there's a concept of drift and there are different things you need to measure and detect while a model is live in production. So before we start talking about all of the different tools and concepts and techniques out there, let's look at the picture of a hammer. Because if all you have is a hammer, everything becomes a nail. And if you only try to use one tool and you try to use a single tool for all jobs, then you'll start to realize that maybe 75 of the jobs that you have there, you'll start to realize that your current tool may not be the best tool for all those 75% of the jobs. So the best move here is to be aware of all the possible options out there, because the best tool for the job depends on the actual context on what you're trying to solve. Maybe it's going to be the team that's going to work on the project. Maybe there's already an existing tool being used for the job. And if there are certain machine learning frameworks that's already being used, why replace them if it's the best tool for that specific context? So there's going to be a lot of argument between, oh, this tool is better than the other tool. What's important here are the concepts, because once we understand the concepts, most of these tools more or less are working on top of the same set of concepts. So now let's talk about the first important concept, serverless. So what do we mean by serverless? So there are different ways to define this. One way to think about it, so one sure thing that you are probably aware when talking about serverless is there are no servers to manage. Of course, there are servers behind the scenes, but if you are the developer or the engineer, as much as possible, you do not have to worry about the nitty-gritty details of taking care of the server. Let's say patching, system administration work, and so on. So your question would be, is there still going to be some management work when doing serverless stuff? Of course, but it's going to be a bit different and a bit more straightforward. And you want to focus your time dealing with the business requirements, because when you have a requirement, you have a project, it's not about using the tools to build something. It's about solving a specific problem. So if you have more time now, given that you will no longer need to manage the servers, it means you have time to work on the custom stuff. And when you're doing serverless, other things that you'll need to think about would be cost. So for cost, the good thing here is that if you have a staging and production environment and they're using the same configuration, most of the serverless solutions out there scale based on the usage. So if there's only one user trying to use your application, then you're going to pay for the usage of that one user, which is sometimes free, sometimes negligible. And then when your same application almost configured the same way in your production application, if let's say 1 million users use that, the cost will properly scale as well. So that's one of the advantages of using serverless. And there's a lot more, let's say event-driven architectures, being able to do this, do that. But those are some of the advantages of serverless. So the definition of serverless did change depending on who you talk to, but that's one way to define it. The next one would be containers. When you have, let's say, something on the left side, which is a refrigerator, and you have, let's say, fruits there or vegetables, if you are trying to manage things at scale and you want to, let's say, have a microservice architecture, then and you want to utilize some of the advantages of container technologies, let's say self-healing, being able to restart the container, being able to port easily what's in your local machine to production, being able to do some other automation things, then containers will definitely help you do that. So in our examples later, we will combine both serverless and container concepts and techniques to solve our specific requirements. Because a lot of people think that serverless and containers are competing concepts. However, they're completely two different concepts. And we should just be aware of that. So one tip I would share with you, this is a very important one, is to choose whether we build everything from scratch or to use an existing framework. When dealing with complex machine learning projects and workflows, as much as possible, we should be avoiding building everything from scratch unless it's absolutely necessary or it makes sense in that case. However, in most cases, using a specific framework and platform would do the trick. So here's one of the scenarios that I would like to share. Let's say that you have a team of data engineers and machine learning engineers and data scientists working on a project. Let's say we have 4 or 5 members there. And then one of the members of the team, before the project started, decided to build everything from scratch, meaning that the entire project was built was built using something that's custom, and only that developer knows the ins and outs of that platform or tool. And then what happened there is that person resigned. So one of the challenges that we have to deal with is that how do we make sure that the knowledge is transferred properly to the other members of the team, especially if that person is leaving already and joining a new opportunity. So if you were to use something that's available out there, let's say these open source tools like TensorFlow, MXNet, PyTorch, and then for platforms, let's say SageMaker and other alternatives in other cloud providers, which are properly documented and heavily documented, it's also easier to find candidates outside your company and have them join the company because they might have probably used the same set of tools in their own company. And in terms of also trying to predict the other requirements that you have in the future, if there's a new feature, let's say model monitoring, that thing that you built something from scratch may not necessarily have that feature yet. So it might take you an additional 1 week to 2 weeks to build it, while these platforms or frameworks might even be offering it for free, which is already part of the batteries included in that framework. So that's something you need to think about. But most of the time, try to prefer something that's not built from scratch, meaning use an existing library or framework, especially when you're dealing with more people in your team. The next one is making sure that the tool and framework or platform that you're using is flexible enough to handle your needs. Of course, when getting things started, you'll be surprised, wow, this new tool is able to solve my machine learning project and requirement in just 4 lines, 5 lines of code or something like that, maybe 5 steps. But once things become more complex, it becomes more critical for your platform to be able to support almost anything. What do I mean by that? Let's say that you want to support this 2021 or 2022 new model, which is available out there. If you're not able to use, let's say, containers to easily port your new model to your platform, then you're going to have problems because you're not going to be able to use that model in production. And generally, when there's a new architecture or model out there are cases where the performance or the results are significantly better than the previous model families out there. And you will be tempted to try this out and compare with what you have. But if you are unable to test out different models in your platform, then that's going to be a limitation or blocker. So now, when we include container technologies and techniques in our platform and in our pipeline, you'll realize that actually things are much easier now, because if there are different members of your team and they prefer different tools, we can actually combine them and even use different languages. So for one thing, let's say data preparation and cleaning, we have a specific container there, which is primarily focused on data preparation and cleaning. So we start first with a small data set, and then we try this library, maybe in R or something. And then that R library or R package would be cleaning the data using custom scripts inside the container. And then when you run it, you'll be able to deal with, let's say, larger data sets when you are now going to deal with production level requirements. The next one would be model training and hyperparameter tuning. So if you have a specific container there, let's say you have a custom code in Python and you're using this new model or algorithm, then feel free to use that. And your platform should be able to deal with all of these different requirements with each container just trying to communicate with the other modules or components of the workflow or system. And then when you deploy it, the goal here is to find a way to deploy it really fast when you're doing proof of concept work, or when you need to use a specific set of tools. Let's say you want to build your own Flask API. So this is one example of the custom script, and we're just using we're just using a dummy model or dummy architecture here. So what we have here is we load the data, we prepare the model, and what's not shown here would be the main function which initiates the training task. And then here, when we want to create our own custom API, then we just follow what the platform is providing. And the good thing here is that Sagemaker and other alternatives out there may already be supporting this. Because in most cases, people will just follow the Hello World tutorials and not really dig deep into what's really possible out there, especially when you have the capability to customize things further. So you will need, of course, the coding skills, the DevOps skills, and things to and other coding lines of code that would allow the API to be as flexible as possible using, let's say, additional configuration parameters. Let's now talk about hyperparameter tuning or automated hyperparameter tuning. When you're doing machine learning and machine learning engineering, one of the things that machine learning engineers and practitioners and data scientists are doing is that they run training jobs and they check the quality of the model using evaluation metrics. So there are multiple ways to do it. If you were to do it manually and it takes, let's say, 2 hours to complete the training job, then if you need to run 5 training jobs, it might take you 2 plus 2 plus 2 until 10, right? So 2 times 5, especially if done sequentially, especially if done manually. But with the usage of the cloud, let's say AWS, GCP, Azure, you'll be able to do this in parallel or concurrently, depending on how you want it. Maybe you want the first 4 jobs to run first and then the next 4, which will help save you time. Because in addition to worrying about the infrastructure cost, you have to worry about the cost of the personnel also. So the good thing there is that the automated hyperparameter tuning jobs would automatically configure and tweak the hyperparameters. And then you're going to have you'll be able to produce multiple models, and then what it will automatically do for you is it will choose the best model out of the different models produced by that automated hyperparameter tuning job. In SageMaker, one of the things which is kind of hard to find, but it's really there, is performing hyperparameter tuning jobs using different model families. So if let's say that you have a three type model here, and then here you have linear regression or something like that, instead of trying to run multiple automated hyperparameter tuning jobs, you can technically just run one and configure it properly to support multiple families, and then just use a single objective metric to be able to help you choose the right model. Yeah. So this is an example also of some code which is also provided in the platforms. So for example, in SageMaker, there's something called SageMaker Debugger. Not a lot of people think that this is powerful, but this is super powerful because it allows us to debug the running training jobs. So for example, you have, let's say, a neural network there, a custom neural network using, let's say, TensorFlow and Keras. Instead of us trying to wait for something to go wrong, what we can do here is we can specify a set of rules, let's say lost not decreasing rule, along with other rules. And then when that rule is violated, you can now use the different serverless services of AWS, let's say SNS or something like that. And then you have the other services of AWS, let's say CloudWatch logs or something like that. Being able to connect those building blocks so that you will be able to work on other things. And then when something fails in your machine learning experiment, a notification will be sent, let's say, to your email address. So these kinds of things, which are usually available for free, that's one of the things that you need to also research, because in some cases people are not aware of the free features out there which you can utilize to speed up the workflow and speed up your processes internally. This is a very important topic, ML explainability. When you have a model, even if you have a really good model, there are cases where you're not able to deploy this into production because, for one thing, you're not able to explain it. And when you're not able to explain it to the stakeholder, sometimes they would prefer a less powerful model, but something that's easier to explain. Because, of course, if you have to deal with regulations and other things, and your stakeholders really want to understand what's happening inside a model, you want to avoid that black box treatment as much as possible. So by adding a couple of lines of code, you'll be able to use, let's say, the SHAP values and the same infrastructure, the same serverless infrastructure of AWS to help you manage these things. Because the good thing here is that you do not have to worry about the actual servers, and you just need to worry about the code. And the servers would automatically spin up, and you would be able to run that ML explainability job and get the results inside S3. So this one is one example of what you'll see. So here, you'll see that you have 4 features, and then 2 of the features are not really contributing to the final output. So here, you'll see that feature 1 and feature 0 are the ones that's contributing to the final output. And you'll be able to know that, okay, if I tweak these numbers a bit, the final value would most likely change as well. There are different ways to deploy a machine learning model. So before we go straight to the workflows, it's important for us to know that there are different ways to do the same thing. And there's no one right answer for everything, meaning that you have to choose what's best for the job. So for one thing, you can deploy a model inside a Lambda function. So if you're trying to significantly reduce the cost and try to make it free, then maybe this is possible, especially if you're just going to trigger your model twice a day, right? If you're going to use the model and invoke it once or twice a day, then maybe you can deploy it inside a Lambda function. It's also possible to set up an API gateway and a Lambda function and trigger the Sagemaker endpoint. That way, you'll be able to make things a bit more custom in some cases, especially if you need to process the data a bit before invoking the Sagemaker endpoint. It's also possible to use API gateway mapping templates with Sagemaker, and we can also deploy the model inside Fargate with additional lines of code. So once things become a bit more complex, the platforms that we have should be able to support us. So for example, if we need to have multiple models inside a single endpoint, if let's say we want to use different types of containers inside that endpoint, then we would be able to save on cost also, because instead of us having multiple endpoints for each of the models, it's better to have a single endpoint for multiple models, especially if we want to optimize on cost also. And if we want to compare their performance also and group them together. Similarly, we can use, let's say, have something like an A/B testing setup using production variants, where if we do not want to completely replace a model in production, we can just do A/B testing there. And as much as possible, we want to do it the serverless way of things, where we do not have to worry how it's done inside. We just configure things a bit, config level, and then the actual platform would do this for us. And finally, we can also deploy a model inside a Lambda function that supports container images. So in AWS, this is kind of new. I think this was last year or last year, where instead of us having to worry about Lambda layers or trying to fit it inside that small container, we can actually use Docker container images and bind it to Lambda functions so that we'll be able to deploy models there. So before we go straight to the workflows, we have to understand that the more experiments we work with, the more focus we need to give to cleaning things up and making things a bit more organized. So the last thing we want to do is to be sad, to be unhappy with the work that we're doing. And in order to be more happy with what we're doing and to be more fulfilled, what's important here is that we should be able to clean things up a bit, make things more organized, and automate things as much as we can. So that if we need to perform the same experiment the second time around or perform, let's say, model retraining, we should be able to do that without having to repeat all the steps and trying to look for the code. Maybe an existing workflow is just there on standby, and then if we need to trigger it because we have new data, then maybe that's one way to do it. So the question there is that, is it possible? And the answer to that is yes. And there are different options out there. No need to use the specific tools that I'm using here, but feel free to research on your own what are the different machine learning workflow tools available. And I'm just going to share, I think, two different options here, which are easily portable and easily integratable with what we have earlier. And here we have something called the Data Science SDK, which helps combine and integrate Sagemaker and step functions. Because for one thing, step functions is a different service which helps us manage workflows using different services of AWS. So with the Data Science SDK, by just adding a few lines of code in addition to our original Sagemaker SDK code, we'll be able to produce something like this. And the advantage of using workflow tools is that even if you are, let's say, kind of hands-off in the project, let's say you're a manager, you do not want to dig deep into the code and find ways to make your setup more observable. Meaning if that there's an error, let's say in the model step or training step, you do not want to go dig deep to dive deep into the code and to the logs and just look at the image. Is there a red here? Is there a green here? Is this process completed? How do we check the other executions? So that at least would help optimize things so that people can monitor this separately. Also, with the Data Science SDK, in addition to what I shared earlier, we'll be able to combine it with other options and make things a bit more complex. So for one thing, if what you saw in the previous slide is just a straight line, what it can possibly do is make things more complex, and there's an if-else condition and so on. And the if-else condition is going to be super useful, especially if, let's say, you want the quality of the model to be above a certain score. So if the score is, let's say, more than 90% or 95%, or maybe even higher than the previous model, then that's the time you redeploy it. There's also another option called Sagemaker Pipelines, where this is fully integrated with Sagemaker Studio and Sagemaker itself. So that instead of us using something that's connected to other services, something that has full integration with Sagemaker Studio is also an option. So for one thing, the lines of code are different, but in a the good thing here is that this has been fully customized and this has evolved after the Sagemaker SDK has been prepared. Meaning that, let's say you have Sagemaker processing, you have a very dedicated scikit-learn processor from the Sagemaker SDK as well. So you don't have to install something different. And at the same time, for every block of code that you have in your Sagemaker Python SDK usage, you'll probably need maybe one line or two for each one in order to connect things. And similar to the Data Science SDK, you'll be able to run this accordingly. And the good thing here is that with the tools that I'm sharing, you'll be able to build more complex projects and pipelines and workflows because you'll be able to build something like this. And my advice when doing something like this is to be aware on how long it takes to test it before it is used to in production. So what do I mean by that? If you're going to use real resources online, you have to be aware that some of the processes here, the oblongs here, might take 3 to 5 minutes to complete. So it might seem just 3 to 5 minutes, right? But when you're iterating and trying to get things working the first time around, you will probably need 30 to 50 attempts to get something to work, especially if you're pretty new to the tools that you're using. So my recommendation here is to replace a certain oblong with, let's say, something that may represent that oblong temporarily, but something that completes within 1 second. So for example, in this case, instead of using, let's say, SageMaker processing and waiting for it to complete 3 to 5 minutes while you're testing things, it's better to replace it first with, let's say, a Lambda function, which would complete in 1 to 2 seconds. So that at least when you're testing things out, you'll be able to do those 30 attempts and 30 iterations within just a few minutes instead of waiting for hours just to test things, because it's kind of hard to test things when you're using real resources. And now that you have that, the next thing you have to think about is, how do I make sure that I do not over-engineer the setup? For one thing, if let's say that your system is supposed to create new workflows by just a few clicks of a button, you have to be aware that you do not need to over-engineer, let's say, the front-end parts. So if your application may not need Redux or other state management libraries because your application just needs an API, then just focus on the API and focus on the documentation so that a lot of other users would be able to use it, depending on the end users. And also, it's important for us to be aware that capability and experience does matter when dealing with these tools and platforms. Because when you're using these tools, we cannot afford to experiment live in live projects. The goal here is for us to get something done in the shortest time possible. So if people are not experienced enough to use these tools, my recommendation here is to have a training program first and small experiments first before trying it in real data sets. Because real data sets may have gigabytes or even terabytes of data. And the larger your data sets, the larger the resources that you will use. So when you're not yet familiar with these tools, you may end up spending a lot of money that you may not really need to spend. So that's pretty much it. It's a very complete yet straightforward talk, and hope you learned something from what I shared earlier. So thank you again, and feel free to ask questions in the other channel. So again, I'm Joshua Arvin, and my topic for today is designing and building complex machine learning engineering projects and workflows, and how we were able to utilize serverless and container concepts to help us solve the business and the project requirements. So thank you again, and have a great day ahead.